bring contributions to the electric and magnetic fields, and we expect many effects from these additional terms that are not contained in standard electromagnetic theory. Yeah, because we have these additional terms, here is it written correctly, the electromagnetic field, normally written as the gradient of a scalar field, contains an additional spin connection vector here. And when you insert this expression into Coulomb's law, you get delta phi equals minus rho over epsilon 0, that's the normal Coulomb law, plus additional terms. And these terms represent an equation for forced resonance or forced oscillation. There can appear resonances, and this term in principle would describe the resonance frequency. It's not constant, so it's not a very simple resonance, but more complicated in nature. But in principle, you obtain such resonance equations from ECE theory, which you would not obtain from standard Maxwell theory. So you can solve such problems then numerically, and this is an example for such resonances. You see in the time diagram of the potential, you get such peaks, and this is a logarithmic scale here. These peaks go up over 10 orders of magnitude in this example here, only to get an expression what the effects are really in certain applications. All this you wouldn't find in standard Maxwell theory. So that was the electromagnetic sector. Since this is a unified theory, we can of course make statements about gravity and mechanical dynamics. The special property of Einstein-Eckardt theory is that you have the same set equations for electromagnetism and for gravitation. So the equations are the same, but the quantities have to be interpreted differently now. What normally is the electric field is transformed to the gravitational field, which you know, which affects the on the Earth the attraction. There are additional fields which are not known from classical physics. For example, the magnetic field has an equivalent which is called gravitomagnetic fields. There are experiments that show that these fields really exist. They are not made by us, but by other people, and could not be explained reasonably. By our theory, we can explain these experiments quite elegantly. The same holds for the vector potential, and we have 4 equations of motion, as you have seen, while Newtonian theory has only 1 equation of motion, in this form the Poisson equation, which is formally identical to Coulomb. Okay, 2 minutes, so I have to go a little bit faster through it. Yeah, there are consequences for cosmology. For example, the creation of galaxies can be explained. There is no dark matter, and also black holes are a little bit different than normally is assumed. So this all has already been developed in the papers of this theory. For you, perhaps it's interesting that quantum mechanics can also derive from it, from the so-called wave equation. the Dirac equation is derived, and that is the basic for Schrödinger equation and quantum chemistry. So the whole field of chemistry follows from this theory. But wave functions are deterministic. That's the main difference. We have no undetermined fluctuations, or so it's all is deterministic in this theory. Quantum field theory, the same. For you, perhaps it's interesting that nearly all chemistry laws follow from the Coulomb law, and I showed you this resonance equation with an extension of the Coulomb law, so I expect that these resonances will show up in nature, in atomic physics, molecular physics, even to biophysical effects, I think. So it's a mainly unexplored field, and a lot of research is to do here. Yeah. Let me conclude the achievements of this theory. You have seen that electromagnetism can be explained on a geometrical basis. It's unified with other fields in physics, gravitational field, and the fields of quantum mechanics down to nuclear physics. And this approach gives a good basis for a lot of novel applications, and it cannot be seen what is possible. I think very new, a lot of new developments are possible by this. Last slide, who are the people who develop this theory? It's done by the so-called AIAS, Alpha Institute for Advanced Study. It's a globally distributed institute which works over internet, and the mission is to develop this kind of unified theory and its applications. We also are very interested in work on application of this theory. It's one property of it that it's easily applicable. It's not a gray theory anywhere, that you can really do concrete things with it. The president of the AIAS is Myron Evans, is a very renowned scientist who wrote over 750 papers, which are all available on our website, which I didn't place here. It's aias.us, and the main work is also available in 6 books, 6 monographs, which can be bought. Yeah, that was it. Thank you for your attention.
Thank you for your interesting presentation. And what questions?
Скажите, пожалуйста, вот все эти физические явления, они относятся в общем-то, к эндогенным факторам, которые влияют на биоорганизм, да? И поэтому...
Если это часть вопроса, я
да.
Итак, относится ли это к эндогенным факторам?
Физические все факторы, которые были перечислены и предыдущими 3 докладчиками, да, можно отнести как к экзогенным факторам, влияющим на